because of the presence of root 5. Rational multiplied to irrational will give us irrational. Now see this next one. If I say this thing, this is 7. 7 is rational. But if I say root 5, so this is irrational. Now, division of rational and irrational. How I know root 5 is rational? From here. Root 5 is irrational. Now, rational divide by irrational gives us irrational here. So, the second one, 7 over root 5 is also irrational. If I see the third problem, this is irrational, but this is your rational number. Now, rational number plus irrational number, it makes it irrational. So the third one is also irrational. Now, if we talk about the pi minus 2, so what we have observed, pi is an irrational number, but 2 is rational. So irrational minus rational, it is also irrational. Okay, so what we have observed, all these numbers are irrational. Why they are irrational? Because we have observed that by some way they are going to multiply with the irrational number, they are getting divided by the irrational number, they are getting added or subtracted by irrational number. If there is a presence of irrational, so it will make whole term irrational. You can see that for the first one, rational multiplied to irrational, you got irrational. Then second one, rational divide by irrational. See, multiplication, that made it irrational. Division by irrational made it irrational. Then addition with irrational made it irrational. Subtraction with irrational made it irrational. So in any way, if irrational is present with a rational number, so that is going to make them irrational number. So this is the way we decided these all numbers are irrational by this concept.
So the question is, every rational number is option A, a natural number, option B, an integer, option C, a real number, and option D, a whole number. It is asked every rational number is. Option A is natural number. So dear student, for option A we have to check that is every rational number a natural number. If I write 2 by 3, is this rational? Yes. 2 by 3 is a rational number. Is it a natural number? No. We can write but it is not a natural number. So we can say every rational number is not a natural number. There may be some rational number which are natural. If I write 10, 10 is rational and natural also. But it is asked every rational number is a natural number? No. Every rational number is not a natural number. This is an example. 2 by 3 is rational, but it is not a natural. So option A is wrong. Then option B, an integer. With the same example we can say 2 by 3 is rational, but 2 by 3 is not integer. This is rational, but this is not integer. So option B is again wrong. A real number. Yes. If we write a rational number, then it must be real, because we know that the real number is classified into two types. One is rational and other is irrational. This is the concept. So every rational number is real and also every irrational number is real. If we combine all rational and irrational number, we get real numbers. So every rational number is real. This option is correct. 2 by 3, 3 by 5, any number which is in the form of p by q, where q is not equal to 0, p and q are integer, it is rational and it is real also. Option D, a whole number? No. With the same example we can say for D option also, 2 by 3 is not whole. We have written that 2 by 3 is rational number, but it is not a whole number. So just option C is correct. Every rational number is real. So we have option C as correct answer for this question.
we have to add this one. See, for adding this, we can write this is given 2 root 2 plus 5 root 3, and then we have plus this and this. So this is root 2 minus 3 root 3. Now see, before doing this problem, we should understand one thing, like the addition or the subtraction, they're only valid, they can be done if they have the same irrational parts. Like see, this is 2 root 2 and this is root 2, both having the same irrational part, this root 2 and this root 2. So we have to add them. So that is going to be 2 root 2, we can pair it together with root 2, this one, and plus this is 5 root 3, 5 root 3, and this is minus 3 root 3. Why we are pairing it up? Because I told you in case of the addition or subtraction, they should be under the same root. Like this is root 2 and this is root 2, so they can be added, and this is root 3 and this is root 3, so they can be subtracted. So for doing this, first of all make the pairs as we have done here. Now see, this is 2 root 2 and this is root 2. See how can we add it? See, this is the, you can say this is 2 and here nothing is, so 1. Now 2 plus 1, 3. And this root 2 comes as it is. So this is 3 root 2. Now plus, if we see here, this is 5 root 3 and this is minus 3 root 3. So we have to do 5